I have here 3 blocks that are identical in the sense that they are all the same size and they are all painted black. But this one is made of steel, and this one is made of aluminum, and this one is made of wood. On which of those 3 blocks is the buoyant force the greatest? Talk to Nimrod. On which of those blocks is the buoyant force the greatest? The answer is not the wood. Okay? Both of the metal cubes, where they are, water used to be. They are displacing an amount of water equal to their full volume. The wood, on the other hand, is floating with half of its volume above, half below the surface. That means only half of its volume is displacing water. Whatever buoyant force we have on the aluminum block, we only have half as much buoyant force on the wooden block. It floats because it's so much lighter. And indeed, we know that whatever the buoyant force is on the wooden block is equal to the weight of the wooden block. Okay? Now, I just gave you the answer to the next question, so we should get this all correct. Which block experiences the larger buoyant force? A, B are both the same. Again, I just gave you the answer. If ever there was a chance to get 100%, this is it. Don't let me down. Okay. Oh, dear. These 12 people are just thinking about something else. Yeah, okay. Regardless of whether something sinks or floats, the buoyant force is going to be equal to the weight of the liquid displaced. This one is displacing much more liquid than this one, and so it has a much greater buoyant force. By Newton's second law, if they are floating, that buoyant force also has to be equal to the weight of the object. That means that these 2 blocks cannot be made out of the same kind of wood. The density has to be different for the 2. Okay? This has to be a dense wood like oak. This has to be a less dense wood like balsa wood. Now, indeed, by looking at how it floats in the water, I can tell you what its density is. If this is floating with 80% of its volume submerged, it's got a density that's 80% that of the water. I'll show you that in just a moment. This one is floating with only about 20% of its volume submerged, so it has a density about 20% that of water. Now, what should I remember? What should I take away from this lecture? Well, there's only 2 things. Archimedes' principle always applies, always, whether it's floating at the top or sunk at the bottom. The buoyant force will always, always, always be the weight of the fluid displaced. No exceptions. No exceptions. If the object is floating, you get a second tool in your toolbox. And that is, there's only 2 forces. Buoyant up, weight down, and it's got no acceleration. So that means that the buoyant force also has to equal the weight of the object. The 10-ton ship, if it's floating, has a buoyant force equal to 10 tons. Okay?